So example 5 says, at age 30, to save for retirement, you decide to deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much will you have from the IRA when you retire at age 65? So we're doing $100 at the end of each month. So that tells me that we're going to use this formula. One second. All right, because remember, this is different than what we did before. We know we're going to use this formula because we're doing $100 at the end of each month. It's not a one-time deposit, okay? We're not just going to deposit $100 and let it sit there for 10 years. Every month, we're going to put another $100 in. So we're going to be building interest on interest as well as interest on our new amount. So that's why our formula is a little different than what we've done in the past. But our variables are the same. Do I know A, the ending amount?
No.
No, that's what we're after. How much will you have when you retire? Do I know P?
$100.
That's the amount we're depositing each month, so $100. All right. R? 9.5%, which is what? 0.095. Good. I'm just going through my variables in the equation. So N, number of times compounded.
12.
Why 12?
Monthly.
It says compounded monthly up there, so that means 12. And T, do I know the time in years?
35.
How'd you get 35?
65 minus 30.
Good. He's done at 65, but he didn't start depositing until he was 30, right? So my time is 35. All right, so let's plug into our equation. A equals our P times, parenthesis, 1 plus R over N, raised to that N times T, and then minus 1, all over R, 0.095, divided by N, which is 12. All right, so a piece at a time. So you said PEMDAS, we're going to use parentheses, and we got parentheses inside. Remember, brackets are the same thing as a big parenthesis, okay? If you want to, you can change it to it. They're just usually used when there's already a parenthesis inside of it. So inside the parenthesis bracket there, we have more parentheses. So let's just do that part. So A equals 100 times, actually, you know what? Inside that parenthesis, well, we got that fraction we got to deal with, don't we?
Yeah.
So let's do that. Let's do our fraction there. We can go ahead and multiply those in the exponent, can't we?
Yeah.
And then notice I've got that same fraction down here.
Yeah.
So let's actually do that first.
Oh, my Lord.
So we got the A equals 100 times the parenthesis bracket parenthesis 1 plus was 0.095 divided by 12.
0.007916.
Hold on, 0.0079. I'm gonna go ahead and do that. All right, raised to the what's 12 divided by 35?
Shouldn't we multiply?
Yeah, it's up in the exponent together, so it's okay.
What?
12 times 35? 420. And you already did the 0.095 divided by 12. You told me it was 0.0079. All right, so next we can add what's in the parentheses here, right?
Yes.
So we got 100. What's 1 plus 0.0079?
1.0079.
Look at y'all. You did it without a calculator, right?
Nope.
Oh, jeez. Okay, so what do we do next?
Raise that to the
Exponent.
420.
We're going to do that exponent there. All right, so A equals 100 times, what's that exponent? I mean, what is 1.0079 raised to the 420?
27.5.
27 point, give me 3 decimal places.
247.
247. And then minus 1 over the 0.0079. Okay, yes, now we're going to subtract 1. So we got A equals 100 times. Didn't have to use a bracket or a parenthesis there.
26.247.
Good, 26.247. And then still over the 0.0079. What's next? Okay, multiply what's on top. It's just going to move that decimal place over. Y'all sure y'all rounded that correctly? At 20.
It should have been. We didn't round it.
It should have been an 8, yeah.
That's what I said.
I didn't hear you, I apologize. So that should have been an 8, which is just going to make this an 8.
Oh.
So, oops, I shouldn't have wrote the 100 though, because I was multiplying it. I was distracted talking to y'all about that. Alright, so when you multiply it, you get, what, 2,624.8
Yes.
divided by the 0.0079. And then, yay, we get to divide it. And we get A is equal to 300. Help me. I don't think I got 326.
33225.
There we go. Yeah, 332,260.
53.
Oh, thank you. 253.16.
Yes.
So I did it right.
All right, so that's how much that annuity will be worth when they retire.